Hello everyone. On this video I'm going to show you how to set up a project from scratch and to start getting familiarized with the Nucleo L476RG development board from ST Micro. In order to do that, I'm going to use a IAR Embedded Workbench, and I'm also going to do the following videos programming everything in C++. The other thing I'm going to do is I'm going to briefly show you how to use the STMQ code generator tool from ST Micro to get the necessary files to set up our project properly. The other thing I wanted to briefly talk about before getting started in more detail is that for my templates and tutorials I'm going to be using C++. I know that some people may think that maybe C++ is not suitable for embedded systems. However, there's a presentation here that I'm going to post on the links below so you guys can check, and there's a senior field applications engineer from IAR Systems who does a very good presentation here and stating what things are really more expensive if we develop in C++, and you will find that there's actually, when you look at the summary, most of the things that you could use from C++ are actually, they don't imply any more overhead in your development. So the reason why I like to do it this way is because there's not much information or tutorials or code examples written in C++. Most of it is C, and also because of all the benefits that I can get pretty much for free. I can use encapsulation, classes, namespaces, and operator overloading, and all the things that you can get from C++. For the other stuff, obviously you want to be careful. You don't want to be using like dynamic memory and things like that because the resources here are limited. So as long as you keep that in mind, I think, in my opinion, also that is totally safe to develop for embedded systems using C++. Okay, so let's get started. The first thing I'm going to do, I'm going to go to the ST Microelectronics website and look for the information for this Nucleo board. So I'm looking for the Nucleo L476RG. So let's get that. So this is the board I'm looking for. This is the one I'm going to be using. There's a bunch of information here, resources to get started. One in particular that I find very useful is this document here in the user manuals, because it contains relevant information. So I'm going to have this one open here for later on. You need to go to IAR.com and then go to products, IAR Embedded Workbench, select ARM, read more, scroll down and download this free trial here. If you select the Kickstart size limited evaluation license, it will give you permanent access for projects which is the code is up to 32 kilobytes. So that's going to work out fine for what we're going to do here. So in order to get that license though, you have to register. So I already have done so on my computer. So the other thing is that you have to go to this website here, Sayer.com. There are some things here that I will really recommend you to install. You select here JLink, and then you go to tools and you get JLink Commander. I will suggest you to install this because this is going to help you when you have issues with not recognizing the MCU or having to erase the memory for some sort of issue that you could have, any kind of issue. The other thing that I would like to do here, which is entirely optional, but I like to do so I can use, because these ST Micro boards, they come with the ST-Link. So I want to use JLink for debugging because it's faster. So I go here to download JLink JTrace. So in my search here, I can go ST-Link, and you'll find this reflash utility. So this one, what it does, it converts your board from ST-Link to J-Link. So what I'll do in this case, I'll download it. Just 1 second here, find the directory where this is. Where Nucleo 64 tools, so we got that. So we're going to extract it, and it extracts that, and you just execute it. So I'll show you here what you can do. For example, it has to be accept with the capitalized. So in this case, my board has already been converted to J-Link. So what I'm going to do here, I'm going to restore ST-Link just to show you how this actually works. So right now my board is like it would be like if I first purchased from ST Micro. So I'm going to select one, upgrade to J-Link. Oh, I have to wait for 10 seconds. Let's see if we recognize it now. Just gonna reopen. Accept. So I select the option 1, upgrade to J-Link, and what it does see, it recognizes that I have an ST-Link version 2.1. So right now my board is converted to J-Link. So that way when I select the debugger on IAR, I will select J-Link instead of ST-Link. Okay, so the third tool that we need to use is the STM Cube MX, which I already also have installed. This is the tool that ST Micro provides you to get started with a code template, but it's all in, it creates a project in C. But I'm going to use it to extract some relevant files that I need for my C++ project. So what I'll do here, I'll go File, New Project, and then I will select by board because it's easier. So I go, our board is, sorry, it's not that one, it's an L4, and it's a Nucleo 64, right? And it's a Nucleo 64 L476RG. So I'll double click on this one, and this will show me the board here. You can actually explore these. You can see, click on a pin and see which signals you can have available there. So you could you know, multiplex and have that particular signal on that particular pin. It also shows you the clock configuration. Like there could be several tutorials just to understand how the clock works, so I'm not going to really get any deeper into that. All I can say is that I'm going to use a PLL clock, so I'm probably going to be living around here, and I'm going to set this at 80 megahertz, and I'm not going to do any division for the peripherals clock, so it means that whatever system clock I have, my peripherals are going to have the same clock. Now when I go to the project manager, I have to give a name for this. Let's say template 1, and just go basic. I select eWorm for IR. That's the minimum version, nothing to do there. I leave all the same. For the code generator and advanced settings, oh, one thing here. For example, if I want to enable anything here, for example, I will enable the timer 6, which is one of the two most basic timers of the microcontroller, also together with the timer 7. And let's say I want to enable user 2, which is the one that is connected to the virtual COM port that the board creates. Let's say, for example, I'll show you here. The moment I connect this board, let's look at my COM ports. So the moment I connect this board, it creates a virtual COM port that in this case is going to be, where did it go? COM 11, right? And it recognizes already as a J-Link. CDC UART. So if I ever want to test this communication, like a hello world, send and receive, something like that, if I want to use a program like, I don't know, TerraTerm, Party, whatever, any of those, I will have to connect to this port to talk to the board. Okay, so if I select more peripherals here, you will find in the project manager that more things are added here. So these are the libraries that the system will create for you. Normally, if you select this LL, they are going to be the low level libraries, which is like more closer to the register level. In any case, I'm not going to use those, but just so you know, they are there. The other thing too is that in the project configuration here, I selected, where is that, in code generator, I selected that, see, copy all used libraries into the project folder. If I copy only the necessary library files, it's going to only copy the ones that's shown, being shown here, right? So, but in this case, I will just generate all of them because I'm gonna have them there in case I need to use them later on to test something. I think that's all we need to do, and we just go generate code. The project already exists, so I'm going to overwrite it, and this is going to generate a template that I can open with IAR Embedded Workbench. So I just select here Open Project, and my project is there. So I don't need the STM cube anymore. But this project is a C project, right? It's not a C++. So I can actually convert from here directly, and it will convert it to C++. But I don't want to use certain things from here, so I want to manually create this. Okay, because of the locations and all that kind of stuff. So what I'll do, I'll just open another instance of IAR, and I will let's say I have already a workspace. I don't have a workspace, so I will create a new workspace, and I'm going to save it right away. Save workspace, and this is going to be in here. So this is going to be Nucleo L476. That's how I'm gonna name my workspace. So I'm going to add a project to this workspace. Project, create new project, and then I'm going to select a C++ project. I also have IAR for MSP430, so that's why I have this drop down here. Just click OK, and it's going to ask you to save your project name. I'm going to create a folder here just called project, just for the way I want to organize it. That this is totally up to you. STM32L476RG, that's how I'm gonna name it, and that's gonna take a while to create your project. So because it's gonna be looking for the devices that are available and supported, and you still have to go and set up your proper device. For some reason doesn't prompt me to select the device, but we can definitely do from here. That's my project, so we can go options, and then when it comes to the device, see that is a generic device selected here, so I go to device and then STM32L4 L4X6. So we are leaving here STM32L476RG. That's our microcontroller. There's something else. Oh, that's gonna add that for now here. So what I'm gonna start doing, I'm going to try to, this is a little tedious, but we only have to do this once. I'm gonna try to replicate the same structure that they have here, just to making it a little more understandable and easier for later, I guess. So I'm going to add a group. I'm gonna name it application, just like in the other project. On the left I have the project, C++ project that I created, and on the right I have the project that the STM cube generated for me. So inside the application folder, I'm going to create another group, just like in there, like it's called a worm, and also a user. All right, and I'm also going to create another group, which is the drivers group, and inside the drivers another group which is CMSys, and then another group that is called same as this one. I just want to copy paste the name, just being lazy here. Okay, and here I'm going to add the things that I need to add. So what else? I would like to go to this folder where I have the project structure. So I'm also going to put this one on the right, and I'm going to go to my folder, where I have my project. So I'm sort of going to create the same structure as well. So I'm going to create an includes folder and a source folder, and also a drivers folder. In the drivers, I'm going to go into this one, and I'm going to copy these two folders from the other one here. However, I don't need everything, so I only need device and include. The other stuff for now I don't need, so I'll invert selection and remove all that. Even for device, I also need only 3 files from here, because this is including all the other devices. It's totally up to you. You can leave them there. It's just that annoys me a little bit, the fact that they still live in there. So and for the includes, I think I'll sorry, for the source, yeah, I also don't need these ones actually. I don't need any of these ones. How much is this? Oh, well, I guess I could leave that there, but just so you know, it's not really necessary. And also to my project folder, going up, I'm going to add this 2 files I have here, which is the assembly file and the memory configuration file, to the project. Now for the drivers, I got the HAL libraries here in case I need to use them later, and for the CMCs, I got a little bit of a mess here because I don't like this, like so many different folders. So I'm gonna copy over these ones here. What is the other stuff? For the source code templates, I actually don't need any of that. I just need this file, so I'm going to move it up to here. Or I'm actually, what I'm gonna do is just, this is very annoying, like it's so many files that you don't need. I just think it makes it a little confusing to have all these files here. So I'm just gonna move this, I moved that one already, so the source folder, I'm gonna move it up a level so they can be here. Alright, so I like the way this looks now. I got the source file I need, the includes, and everything organized like more neatly for the folders. Alright, so I'll go back to my IAR and I'll start adding those files here. So I need to add the assembly file, the .s file. That one is located in the project here. Let's add it. I also need to add to the CMSys folder that's in drivers, CMSys source, this file. And I'll actually add all the other ones here. Like I said, I'm not going to use these ones, but in case you want to test a peripheral like quickly, you can use these libraries. And they're actually all here. I'm going to add all of them. I think there's one here that's going to give me an issue, so I'll probably erase, but I think that's all I need for now. Oh, one thing here. So for the preprocessor instructions, I need to actually copy and have some of these folders here, so he knows where to look, and this defines. There's one more define I need to add there. Just 1 second. Oh yes, double underscore C++, so it does know that it's a C++ project. And I'm also going to, since I moved this up several levels, so I don't need this anymore. So with those includes, I should be okay. All right, let's try to see. We're gonna move this one out of here. Let's try to see. So it is missing a file. Okay, so what we need to do here, and what I forgot to do was, I have a file missing, and it has to do with my, I'm gonna go back to my STMcube project. I think I got some setting here that if I go to my project manager, so I'm gonna change this to advanced, and on the advanced settings, I'm just gonna change the GPIO to HAL, just so it just had at least one of these HAL libraries for generating the file that is missing. Let's see if it generated. Yeah, it generated now. Just take this out of the way. So it generated another include, which is actually the one that is missing here. So I'm gonna copy this over to, not this includes, this includes here. So I'm gonna copy paste it here. All right, so this is actually not necessary, but it's because I added all these libraries here in case I want to test quickly some peripheral. Is the reason why it's bugging me. Okay, so and it's still complaining about something here, but what I'll just do in this case, I think this is this one. Yeah, so I'll just eliminate this one, remove it, because it's looking for some constants that are not present in the project. So I'll just remove that one, and I'll rebuild again. Okay, so at this point I have a project that compiles. Okay, let me just check here that I'm not missing anything. Yeah, this is one of the things I needed to, I wanted to change. I'm just not going to use the default linker file that they have here. I'm just going to go to my project folder and link it to the actual file. This is right here, project. Okay, but I don't want an absolute path, so I'm gonna go here, proj_dir. That's gonna give me a relative path to the project directory. So that should actually work. Yes, perfect. That works. Let's see if I'm missing anything else. Optimizations. Probably you can play with this later. Right. Oh, this is very important. See, in here, if I don't change this, no code is going to work because right now the debugger is in simulator mode. So I have to select here the JLink JTrace. If I never did a step that I did before when I switched the ST-Link to JLink, I would select ST-Link. But in this case, my board is already JLink, so I can actually select that one. And there are some configurations here. We're just going to leave this by default. Let's see, we build. And let's try to load the code. It gives me this message. And it runs the code. Of course, the code is not doing anything. It's not even having an infinite loop, so it will just run once and it will exit. Okay, on the next video, what I'll do is just set up a blinking LED just to start, and create some more classes for setting the clock and the basic peripherals to start working with it. Alright, thank you for watching. If you have any questions or suggestions, feel free to leave a comment and we'll discuss it on the next video. Thank you for watching.